Here's 3 ways to create a RAG agent, starting with a method that takes less than 60 seconds. So quick recap, RAG is essentially telling an LLM to go and fetch some data before it generates its response. And we use RAG to make that response more accurate, personalized, and up-to-date. So here's how it looks in theory. We ask a question to an LLM, and instead of the LLM just generating a response straight away, the LLM is now going to look at a content store where we've given it some kind of data, some files, that's going to improve the response that we get. So if you've ever used OpenAI assistants or Claude projects, this might look familiar. And the reason for that is that they're basically using RAG. Now, we're going to build a RAG agent in NAN in just a moment, but the easiest way of getting up and running is to use Claude projects or OpenAI assistants. So you can just drop your files. I'm going to upload the Bitcoin PDF. And I can then ask it a question like, what size is a block header with no transactions? It should then look through the white paper and find the answer 80 bytes. So if we look at how this is run, we can see on page 4, it's returned the exact quote and found the answer 80 bytes. Now that's exactly the kind of output you would hope to see when using RAG. Now let's look at how to build our own RAG agent in NAN. So first I'm going to show you a really simple implementation of a RAG agent. We'll then talk about some of its limitations and how you can make it better. So there's going to be 2 parts to our RAG agent. Firstly, we're going to need to create a way to add data into our vector store. We then need to create the RAG agent that's going to reference that vector store and give us our response. So I'm just going to create a really simple workflow. So we're just going to do on-click, go to Google Drive, and download the Bitcoin manifesto. I've already connected my Google Drive, so if you haven't done this before, you'd have to set up your Google Drive connection. We're just going to run that. That's going to get the Bitcoin PDF. Now this is a PDF, so we need to get the text out of that PDF. So I'm just going to add a node to extract text from that PDF. So we're just going to run that to output this text. So now we can add our vector store, and I'm going to use Supabase today. We'll talk about some of the limitations in a moment. But firstly, we're just going to add that node and select add documents to a vector store. Now I'm just going to wipe these credentials just so I can show you how to set this up from scratch, because I assume you probably don't have Supabase already running. You'll need to create a free account on Supabase and then click create a new project. We're going to just name this NAN, generate password, create new project. Then we need 2 things to set up our credential. We need a host and a service role secret. So to get the host, we click project settings and you want to click on the data API. And you want to copy and paste this project URL. So I'm just going to click copy and pop that in there. Then for the service role secret, we need to go down to API keys and you want this one. So we're going to click reveal and copy, stick that in there, hit save, that should work. So now we need to set up a table as a vector store. Now you don't need to worry about how to do this. There's an article that has this SQL. I'll link to this in the description below. And you can just copy this, go over to the SQL editor, paste it in there, hit run, that's done. So that's created a table. If you go to table editor, you should see there's a table called documents. So now when we go back to NAN, you can click here under table name and you should be able to just select documents, and that's going to use that table to add in the data that we're going to vectorize. It's going to embed it into that table. So there's a few things we still need to do. We need to add a data loader, which is going to split our content into chunks, and we need to add an embedding model, which is going to vectorize those chunks to be added into the database. So to add a data loader, we're just going to use the default data loader, and we can just leave the text splitting as simple for now. We'll touch on that again later. And for the embedding model, we're just going to use the embeddings OpenAI model. For most use cases, this is absolutely fine. Again, I'll talk about a different approach in the next part of the video. So I'm actually going to cross these over and drag this over here. This will become a little bit clearer in a moment. But everything now should work. If we run this workflow, it should now take the Bitcoin PDF, get the text from it, chunk it, and then be able to embed it into the vector store. So if I run that, we should see we've got no content at the moment. That's running, it's embedding it. And now if we refresh, it's now embedded all of those chunks, and we can see the vectorizations in this columns. These are basically just numbers representing this content. So part 1 of our RAG agent is done. Next, we're going to create the RAG agent that's going to reference our vector store. So I'm going to add a chat trigger, and we're going to connect this to an AI agent. We'll hook this all up in a moment. But we're going to give this a tool to access our Supabase vector store. So we'll give it access to the documents. Now, very important, we need to make sure the embedding model that this vector store has is identical to this one. So this is why I dragged this over here. So you can just go and add in an OpenAI embeddings node here, but I just find it cleaner to connect it to the same one. So memory, for now, I'm gonna just add simple memory. There's a bit of a limitation with this. Again, I'll touch on it later, but we're just gonna keep it nice and simple for now. And then the chat model, again, we're just gonna go for OpenAI. I'm just gonna drag this over here just to try and keep this looking a little bit cleaner. Let's do that. And then we're gonna just add an action to respond to chat. So first thing I'm gonna do is change the response node of the chat trigger to use the response node. This is just gonna mean that the response node knows to listen to the trigger and we can get a nice loop there. Now, the next thing we need to do is to correct this prompt. We're gonna take chat input and say, based on the user's input, use the connected tool, the vector store, to return a relevant answer. Now, obviously in real life, we'd make this prompt better, but just to encourage this agent to use that tool, this is just giving it a little bit of a nudge. Okay, so we should be able to test that now. So I'm just going to drop a question there. What is a block size? We can see it's running the agent, going to the vector store, and it's come back with an answer. And we know that this is going to our vector store, not only because we can see down here that it's querying the vector store, but the response is also coming back specifically about Bitcoin. It's not talking about block sizes generally. So we've got a working RAG agent in NAN, and this is going to be absolutely fine for basic use cases, but it's likely going to run into a few problems, particularly as the size of your vector store gets larger. So we can generally bucket those problems into 4 areas. We're going to have inefficient usage of tokens, irrelevant responses, messy data, and timeouts and latency. And the solutions to these are basically making the retrieval process more efficient. We want to have smaller, better chunks. We want the chunks to be more relevant. We want them to be split sanely so the data structure isn't a mess of text. And we want to give the RAG agent more resources, more memory. So I'll show you a few ways that we can do that inside NAN. The first thing we're going to do is re-ranking. So if we go into the vector store that the agent's connected to, instead of returning a kind of unordered response from the vector store, we're going to first order that response in order of relevance. This is especially important if the number of results that you're fetching is quite low. If we turn re-rank results off, but we return a high number of responses, it's going to go and get everything. It's going to make it quite inefficient, but it's less of a relevancy problem. But if we reduce that, which is a good idea, we're going to want to re-rank the results. So that's going to add this where we need to connect it to a re-ranker. Currently, the only option we've got available is the Cohere re-ranker. We'll need to connect Cohere and then just copy our API key. I'm going to copy that, pop that into NAN, and that should connect. And we now have re-ranking. That alone is going to improve the quality of the responses we get back. So the next thing we're going to do is improve the data structure going into the vector store. So if we go back to our data loader, at the moment, we're basically just taking text chunks and shoving it into the vector store. There's no tidying up of that data, which means that our AI agent has to work a bit harder to know what chunks to retrieve. So first thing I'm going to do is add some metadata. Now, in my case, this is a bit academic because I've just got the one Bitcoin PDF. But if you're, say, adding 500 documents from different departments or documents with different titles, different owners, you might want to add that as metadata to help the AI agent more efficiently know which chunks to return. So if we just say here, for example, department sales, but you could pull in anything from the documents you're uploading. The next thing that I'll touch on, generally for most cases, simple text splitting is fine. But if, for example, the data that you were pulling into your vector store had a certain structure to it, let's say it's markdown, you might want to split your text based around that. So we can set, for example, the text splitting to custom. That's going to add a text splitter here, and you could add, say, a recursive character splitter and set the option to markdown. This, for example, is going to mean every markdown header is going to be the start of a new chunk. You might need to play around with your chunk size to get this working the way you want, but it just means instead of your table looking like this, where you've got like writer 5.3.31 and the chunks are starting at different points, you have a bit more control over that and just make the chunks formatted in a slightly more sensible way. So that's an option. I'm going to remove it here just because it's not really going to help me in this example, but it's something that particularly as your RAG agent gets bigger, you will probably want to split the text in a slightly more coherent way. Now, the last change that I'm going to make to our RAG agent is around memory. Now, as I mentioned earlier, we're using simple memory at the moment, which is absolutely fine for getting up and running quickly. But the problem is that it's using the memory inside your NAN instance. And that has some limitations. And what you'll find is that particularly if it's making a large query, it might result in timeouts. It's also not particularly fast. Again, as you make larger queries, you'll start to notice a lot of latency, slowing this all down. So my recommendation would be to use Postgres memory. The reason is because Supabase is using Postgres, so it's really just using Supabase's memory. But in order to do that, you will need to set that up. You basically just click connect. You'll need to get your Postgres details from Supabase here, connect the credentials, and that's just going to prevent you having timeouts in NAN and just make this a little bit more robust and less likely to fail. Now, there's a lot of ways you can make this a bit fancier, and if you have any questions or issues, drop them in the comments. One last thing, if you've learned something new, please do hit like, and if you'd like to learn more about NAN, watch this video next, which has some build-along projects, including a pretty cool RAG agent, which you can interact with via WhatsApp.